right? Okay. Fourth is 9, atomicity. You can able to write the atomicity. Write down atomicity. Nitrogen and triple bond and 1 sigma and 2 pi bond. The dissociation energy is very high. AS4 and SB4. AS4 and SB4 are very rare molecules. Mainly they exist in a metallic form, but also exist in tetrahedral atomic forms, right? Corner of tetrahedron means same structure of like that. So this is tetrahedral kind of thing, but in general AS4 and SB4 exist in a metallic bond. Very few allotropes exist in AS4 and SB4, and rest bismuth and all other are exist in a metal bond with the formation of free electrons due to formation of metallic bond, right? So oxidation state, as we have already discussed regarding the inert pair effect. Oxidation state mainly depend upon the two factors. One, see, the valence electron is NS2 and NP3 for all elements. Okay. So to gain the octet, there are two options. One, it can lose all these 3 and 2 electrons. So if it lose all 3 electrons, it is converted to M plus 5, 3 plus 2, and it gain the octet rule. So plus 5 is the one oxidation state which we can able to get, right? Second thing is that as we move down the group, inert pair effect is higher. In that case, it can lose 3 electrons to convert to M plus 2, these 3 electrons. Okay? ये 3 इलेक्ट्रॉन अगर वो लॉस करते हैं तो NS2 एज इट इज ऐसा क्यों रहा? क्योंकि इनर्ट पेयर इफेक्ट हुआ. ठीक है, तो प्लस 3 इलेक्ट्रॉन plus 3 is the oxidation state and the 2 electron are left. So these are the two acceptable oxidation state of nitrogen family. Now there are some element, electronegative element, which can accept 3 electron to get a stable configuration of NS2NP6. In that case, this M consists of -3. -3. Apart from these, you can able to get +1 to -5, all oxidation states. Sorry, +1 to -3. Clear? It depends upon the nature of oxide which we are forming. Clear? So we will get almost all oxidation state from +5 to -3. Oxides of nitrogen mainly exist in +5 form. Oxides of nitrogen mainly exist in +5 form because there is no inert pair effect. It can lose all 5 electrons because the formation of nitrogen and oxygen bond energy is exothermic. Clear? Clear? Okay. Now we'll start with the general chemical property. So there are two type of chemical property. One, we are going through the each and every molecules, and second is the general chemical property of nitrogen family. General chemical property match with all properties of the elements, right? See, nitrogen family all react with hydrogen to form hydrides. All metal react with H2 to form metal hydride of type MH3. Clear? We know that if this metal lost 3 electron, M3 plus, in case of bismuth and all that, hydrogen homolytically formed, and if it accept 2 electron, it gives 2H minus. This M3 plus and H minus form a bond of MH3 having one lone pair. These lone pair are of NS2. These lone pair are from NS2. So nitrogen form NH3 phosphorus PS3. Now it depends upon the electronegativity. In case of nitrogen and hydrogen, nitrogen is more electronegative. Therefore, the oxidation state of this nitrogen is -3. Nitrogen and hydrogen, which is more electronegative. Nitrogen. So all element form hydride of type MH3. So these hydrides are ammonia, phosphine, arsine, stilbene, and bismuthine. Clear? Clear? See, the properties of these hydrides are, if you say NH3, PH3, PH3 is known as same, PH3 is known as phosphate. Now, see, if you increase the hybridization of, central atom hybridization, it is sp3. sp3 means the bond angle are 109. So this is hydrogen, 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 and let's say this is not nitrogen, I'm writing M. Okay, this is lone pair. So there are bond pair and these are lone pair. This lone pair bond pair repulsion is higher or bond pair repulsion? Lone pair bond pair. So can we say the angle is not 109, it decreases less than 109? Okay. Why it is less than 109? Because it come close, so that this angle will be increases. Clear? So if you increase the size of central atom का size जैसे जैसे बढ़ेगा, उससे क्या होगा, ये जो bond length है वो बढ़ेगी, right? And if you increase the bond length, the density of electron in the bond length decreases. And if the density of electron in the bond length decreases, the inter-electronic repulsion between two bonds decreases. So they can come close to each other so that the lone pair and bond pair bond are higher. So can we say that as we move down the group, the central atom size increases? If the central atom size increases, that means the bond length decreases. The bond length decreases. So can we say in case of hydride, as we move down the group, the bond length decreases. Is it clear? No. 7. So see, the stability. How you define stability? Any metal hydride, when heated, it gives H2. At what temperature it gives H2? Higher the temperature, higher will be the stability of this metal hydride. Clear? Now, see, all atoms form bond with hydrogen, which is very small in size, right? So the overlapping is like this. If you increase the size of central atom, it will become larger. So overlapping become weaker. Bond length become longer. Bond dissociation energy is decreases. So can we say that the thermal stability of all hydride decreases as we move down the group? So the most stable hydride is NH3 and least stable is BiH3. Why BiH3 is least stable? Due to strong, longer bond length. Clear? Clear? So higher the bond length, easier will be the dissociation. Okay? So there are two things. One is that bond angle. If you go down the group, the bond angle decreases. Second is thermal stability. If you go down the group, the thermal stability decreases. So most stable is NH3. Least stable is BH3. Highest bond angle is NH3 and lowest bond angle is BiH3. Third, the most important is poisonous nature. All these gases are poisoning in nature, right? NH3 is also there. And the poisonous nature also increases as we move down the group. So highly poisonous is BiH3. Okay. So the most important third point is poisoning nature. If you move down the group, the poisonous nature increases. The stability is also there. So all are tetrahedral, electron and the bond angle decreases. This is it clear? All these hydride are Lewis base. Why these are Lewis base? Presence of lone pair. So easily can able to donate the lone pair. Now Lewis base, why they are Lewis base? Due to the presence of lone pair. If you increase the size of atom, the availability of lone pair decreases. So the basic strength decreases. So highly basic in nature, ammonia. Least basic, BiH3. BiH3, why BiH3 is least basic? Because the lone pair are present in a very bigger orbital. So the availability of lone pair are very less. Clear? Clear? So first one is bond angle. Second one is thermal stability. Thermal. Third one is poisonous nature. Fourth one is basicity. Clear? And one more is that bond length. Sometimes they ask bond length. So if you go move down the group, the bond length increases. If bond length increases, the bond dissociation energy decreases. And all are covalent in nature. All are covalent in nature. See, if you react these metal with halogen, again, there are different type of halogen p block element form, and all are very important. This metal or the element loses 3 electron. Their bond between chlorine and chlorine is covalent. It accepts the 2 electron to form Cl minus, and this M3 plus and Cl minus combine to give MCl3. The bond may be covalent or ionic. It depends upon the Fajans rule as well as the size of this metal. Clear? Mainly they form trihalides, 3 halogens. Nitrogen form trihalide. Nitrogen unable to form pentahalide. Why? The octet of nitrogen is in 8 and the electron present in the second orbit. Second orbit में maximum 8 इलेक्ट्रॉन ही तो रख सकते हैं. तो अगर 3 बॉन्ड बनाएंगे 6 हुआ, 2 लोन पेयर तो थे 8 हो गए. लेकिन अगर नाइट्रोजन के बाद फॉस्फोरस में आएंगे तो ऑक्टेट 18 तक चला जाएगा. इसलिए हमने PCl5 देखा है ना. तो पेंटाहेलाइड्स नाइट्रोजन नहीं बनाएंगे, बाकी सभी पेंटाहेलाइड्स बनाएंगे. क्लियर है? बट आयोडीन के साथ पेंटाहेलाइड बहुत रेयर बनते हैं. PI5 तुमने नहीं सुना होगा, बहुत अच्छा ऑक्सीडाइजिंग रिड्यूसिंग एजेंट है. आयोडीन गैस एलिमिनेट करेंगे, इलेक्ट्रॉन फॉस्फोरस ले लेगा. क्लियर है? So this is also very important. The second point is that all trihalide of this are known, but except Bi3 and Ni3. Nitrogen never form 3 iodine or with 3 bromine. Clear? Dissimilar overlapping. NBr3 is highly unstable. Ni3 never forms. Okay. Now, all are sp3 hybridized, pyramidal in shape, having one lone pair. The ionic character of these halide increase from nitrogen to bismuth. BiF3 is ionic. Why BiF3 is ionic and SbI3 and other halide are partial ionic? Due to Fajans rule. Due to what is Fajans rule? See, this is, let's say, this is the atom A plus and B minus. So this is a positive charge, this is negative charge. So a positive cation and a negative anion, there is a weak force of attraction, which is known as ionic bond, and the energy which is released is known as lattice energy. This is known as lattice energy. Higher the lattice energy, stronger will be the bond. This lattice energy is mainly depend upon the size of cation and anion. Smaller the size, higher the charge, higher will be the lattice energy, and stronger will be the bond. But in case of covalent bond, there is a sharing of orbitals, right? So we classified ionic bond as a strong attraction between cation and anion, and covalent bond has a sharing of these atoms. Clear? Now, see this ionic bond. Let's say this is a cation, and the cation is very small in size, and anion is very big in size. And there is a force of attraction which is known as lattice energy. Now, this cation attract this electronic cloud towards itself. This is what we called polarization of this cation. This is known as polarization. So due to this polarization, this negative charge decreases as well as this positive charge decreases, and the electron will move towards this cation. Clear? So if the electron will move towards this cation, the negative charge decreases. That means there is a covalent character formed between this. There is a covalent character formed between cation and anion. So this is what we call this ionic molecule. There is a covalent character form. Okay. So according to Fajan's rule, smaller the cation, higher will be the polarization. Higher will be the polarization, higher will be the covalent character. And larger the size of anion, easy will be the electron to attract itself. So what we have in the third point, from nitrogen to Bi, the size of cation increases. If the size of cation increases, the polarization capacity decreases. If the polarization capacity decreases, it is unable to attract the electron from negative ion. Therefore, this cation, if it is larger in size, and anion is smaller in size, and it is unable to accept the electron, so it forms a strong ionic bond. That's why we have written that BiF3 is ionic, while rest other are partially ionic. Clear? Clear? Polarization also affected by the inner D10 electron. Let's say there are two cation. One is Ag plus, other is K plus. And Ag plus consists of D10 electron. We know that the D10 electron, the polarization is very weak. So Ag plus, the size will be reduced. If it is reduced, the polarization ability increases and covalent character increases. Covalent character increases. So inner D10 electron, the covalent character always increases. Clear? Now, almost all halides when react with water will give hypohalous acid as well as ammonia. For example, NCl3. Hydrolysis of metal halides. NCl3 plus water. This is chlorine having one lone pair, and it is treated with water in presence of H plus, acidic water. So this H plus will first attack to the lone pair. Now nitrogen get positive charge. Clear? Now further adding upon water, all halogen are substituted. NClO, NClO2, NClO3, or in some cases NClO4 also form. Clear? So I think all of you have written these points. Last one, this last year they have asked the PCl3 and water reaction, phosphoric acid and HCl. This is the hydrolysis of PCl3. If you remember this NCl3 hydrolysis, you can able to see that all form acid. NCl3 gives ammonia, whereas PCl3 gives phosphoric acid. And ASCl3 will give arsenous acid. Clear? So, except nitrogen, all halide will give acids, arsenic as well as phosphoric. Clear? Note kiya? H3PO4 PCl5 when treated with H2O, it give H3PO4 plus HCl. What is the N factor of H3PO4? 3. Why? Because it can give 3 hydrogen. Clear? So you have to remember all N factor also. Clear? So we have done two chemical property. One is the formation of hydride. Second is the formation of halide. So in halides, you can able to remember that nitrogen unable to form bromine and iodine, but nitrogen form NCl3 and NF3. Clear? Oxides of nitrogen as well as oxides of phosphorus are very common, and it form N2O. Nitrogen form first oxide, nitrous oxide, N2O, nitric oxide, NO, dinitrogen trioxide, N2O3, nitrogen dioxide, NO2, dinitrogen tetraoxide, N2O4, dinitrogen pentaoxide, N2O5. Clear? All these oxide undergo redox reaction. See, this is the oxidation state +1 to +5. So this +1 can able to accept the electron and go to negative oxidation state. So these can accept electron as well as lose electron. So in general, they used to ask, for example, if an element accept electron N2O and it is converted to NH3. So what is the N factor of this? N factor is not the oxidation state. Y plus 3. N factor can be defined as how many electron can this one molecule gain or loss. Clear? Oxidation state, you know. What is the oxidation state of OHF? Oxygen. How we define oxidation state? 0. Actually, why am I asking oxidation state? They used to give these oxides with the help of this oxidation state. They will ask you the N factor in a redox reaction or in a chemical reaction. So how you define oxidation state? How you calculate these oxidation state? There are two methods. One is you remember all these oxidation states. Second is the from structure you can able to calculate the oxidation state. See, oxidation state is that if किसी भी एटम को उस मॉलिक्यूल से अगर आप बाहर निकालते हो तो उसमें जो चार्ज आता है वो ऑक्सीडेशन स्टेट है. आया समझ में? जैसे देखो सबसे ज्यादा इलेक्ट्रोनेगेटिव एलिमेंट कौन सा है पीरियोडिक टेबल का? फ्लोरीन, देन क्लोरीन, ब्रोमीन, आयोडीन, सल्फर, एसिड, है ना. मान लो ऑक्सीजन है, हाइड्रोजन. अब हम ये देखेंगे कि बिटवीन ऑक्सीजन एंड हाइड्रोजन विच इज मोर इलेक्ट्रोनेगेटिव. तो ये दोनों इलेक्ट्रॉन ऑक्सीजन की तरफ होंगे ना. इस ऑक्सीजन और हाइड्रोजन में कौन होगा? ऑक्सीजन. तो अब जब इस बॉन्ड को हम ब्रेक करेंगे तो ये इलेक्ट्रॉन कौन लेगा? दोनों इलेक्ट्रॉन ऑक्सीजन ने लिए. ठीक है. जब इस बॉन्ड को ब्रेक करेंगे तो कौन लेगा? ये भी दोनों इलेक्ट्रॉन ऑक्सीजन ने लिए. नाउ दिस बॉन्ड कंसिस्ट ऑफ 2 इलेक्ट्रॉन, 1 इलेक्ट्रॉन फ्रॉम दिस ऑक्सीजन, other electron from hydrogen. So how many extra electron this oxygen taken? 1 from this bond, 1 from this bond. So the oxidation state of this oxygen is -2 and this hydrogen is +1. This hydrogen is +1. So can we say that oxidation state actual में क्या है कि उस मॉलिक्यूल से अगर हम उस एटम को बाहर निकालते हैं तो उसमें क्या चार्ज आ रहा है? ठीक है. नेट गेन एंड नेट लॉस ऑफ इलेक्ट्रॉन. दैट डजंट मीन कि हम ऐसा कर रहे हैं. हम कह रहे हैं कि अगर वो निकलता तो उस पर ये चार्ज आता. तो अब अगर क्वेश्चन ऐसा है कि OH OH, तो इस ऑक्सीजन की ऑक्सीडेशन स्टेट क्या होगी? बोलो। इस ऑक्सीजन और इस हाइड्रोजन में इलेक्ट्रोनेगेटिव कौन है? तो ये दोनों इलेक्ट्रॉन ऑक्सीजन ने लिए। इस ऑक्सीजन और इस ऑक्सीजन में कौन है? आइडेंटिकल है, तो कोई भी नहीं लेगा, तो बीच में रहेंगे। सही है ना? तो इस बॉन्ड से तो इसने एक्स्ट्रा इलेक्ट्रॉन गेन नहीं किए, लेकिन इस बॉन्ड से इसने दोनों इलेक्ट्रॉन गेन किए। सो इट इज -1. दिस ऑक्सीजन -1, दिस हाइड्रोजन +1, दिस हाइड्रोजन +1. Clear? Now, what is the oxidation state of oxygen in this? क्योंकि फ्लोरीन इलेक्ट्रॉन लेगा, लॉस किया इसने +1, और हाइड्रोजन से इलेक्ट्रॉन गेन किया, तो 0. If both are fluorine, then what is the oxidation state of oxygen? +2. Clear? So you can able to calculate all oxidation state if you know the structure. So if I give you the structure of these oxide, you can able to calculate the oxidation state. For example, if this is a chlorine, double bond O, OH, bromine, this is fluorine. What is the oxidation state of this chlorine? -1. What is the oxidation state of chlorine? No. Other center can also post their answers. See this chlorine and oxygen, which is more electronegative? Oxygen. How many electron loss? 2. So this is +2, +3. Gain. This is also gain. So 3 loss, 2 gain. Net loss is, so the oxidation state is +1. Clear? The oxidation state is +1. What is the oxidation state of this bromine? As well as write down the oxidation state of this sulfur, this oxygen. What is the reason for NH3 to be a ligand? Actually, what is ligand? How you define ligand? Ligand is any molecule which can able to donate pair of electron to d block elements or vacant d orbital. Ammonia consists of lone pair of electron. Ammonia consists of lone pair of electron, so it can able to donate electron to the vacant d orbital, right? So therefore ammonia act as a ligand. Poisonous nature is not due to the stability of hydride. That is the property of these elements. They combine with certain enzymes in our body, that's why they are poisonous. That is not due to the hydride donor. Clear? So what is the oxidation state of bromine? 0. Net loss 1, 2. So these are the 2 loss. 3 loss, 2 gain, +1. 3 loss, 2 gain, +1. And what is the oxidation state of the sulfur? plus 4. 2, 2, 4, 5 and 1 gain. So this is the plus 4. Clear? So oxidation state is used to calculate the equivalent weight of these oxides. Equivalent weight of these oxides. Okay. So next slide. See the structure of these oxides. Now you can able to calculate the oxidation state of all these elements. And you have to remember the structure also. This is nitrous oxide. This is nitric. What is the oxidation state of nitric oxide in nitrogen? Plus 2. Here the nitrogen is this nitrogen 2, these 2, no 3 plus 3 होगा. क्लियर है? इक्विवेलेंट वेट हम कैसे निकालते हैं इस ऑक्साइड्स के या किसी भी मॉलिक्यूल के इन ए रिडॉक्स रिएक्शन. सी हाँ बोलो. इक्विवेलेंट वेट कैन बी रिटन एज मॉलिक्यूलर वेट अपॉन, बिल्कुल ठीक, molecular weight upon n factor. Now, what is n factor? Number of moles of electron gain or loss by 1 mole molecule. एक मोल मॉलिक्यूल ने जितने इलेक्ट्रॉन गेन किए या लॉस किए. ठीक है. जैसे फॉर एग्जांपल मेरे पास अगर मॉलिक्यूल है N2O3 NH3 बन रहा है ना. What is the equivalent weight of N2O3? What is the equivalent weight of this N2O3? कितना है? What is the oxidation state of N2O3? Plus 3. What is the oxidation state of this nitrogen? Minus 3. From plus 3 to minus 3, how many electron it gain? 6. 6 electron gain. This molecule consists of how many nitrogen? 2. So 1 nitrogen gain, 6 electron, 2 will gain. So n factor is, so the equivalent weight can be written as m by 12. Simple? Clear? Clear? So some cases there will be the disproportionation of the oxides. Oxide undergo 2 different oxidation states, gain as well as loss. For example, NO give N2O3 and NH3. NO give N2O3 plus NH3. See the oxidation state of this nitrogen is plus 2. This is plus 3, no? This is, so it lost electron, this gain electron. Gain and loss both. So what is the n factor of this NO, or what is the equivalent weight of this NO? Do you know how to calculate the disproportionate reaction n factor, or I will give you the example? Example. See, disproportionate reaction. Let's say bromine Br2 gives Br minus and BrO3 minus. Okay. So bromine give Br minus. So you have to write down two reactions, BrO3 minus. Okay. Now balance these reactions. There are two bromine. This is 1, 2. Bromine 2. From 0 to minus 1, it accepts 2 electron. From 0 to plus 5, it gives 10 electron. Simple. Now you have to balance the electron. This is the 10 electron. This is 2. So multiply this with 5. Okay. Now this is 5 bromine. This is 1 bromine. So total bromine are, can I say 6 bromine transfers 10 electron. 1 will transfer 10 by 6. That is, so the N factor of bromine is 5 by 3. So all these oxide undergo disproportionate reactions with different oxidizing and reducing agent. So like this you can able to calculate N factor. Clear? Clear? एक एग्जांपल और दूं, लिख लिया मिटाऊं? What is the N factor of FeO, IO2 minus and N2O5? All are disproportionate. You have to calculate the N factor of these. FeO, what is the N factor? बिल्कुल, बिना बैलेंस के कैसे बताओगी कितने इलेक्ट्रॉन लॉस और गेन हुए? N factor can be fraction. It is the number of moles of electron. First one, I think all of you have done. Two by 5. Plus 2 to plus 8 by 3, that is 2 by 3. For 3 iron, it is 2. FeO to Fe2O, 2 electron. So 5 FeO transfers 2 electron, 1 will transfer 2 by 5. Okay. iO2 minus, have you calculated? Jaldi. क्या FeO में? हाँ, समझा नहीं मैं. प्लस 2 से प्लस 8 by 3 गया ना, तो कितने इलेक्ट्रॉन का ट्रांसफर हुआ? 2 by 3. तो 1 आयरन के लिए 2 by 3 का हुआ और दोनों तरफ 3 आयरन थे. If 1 iron loss or gain 2 by 3, 3 iron will loss or gain 2 by 3 into 3. 2. Second, IO2 minus, what is the n factor of IO2 minus? 1. 1. 6/5. See, IO2 minus gives IO3 minus. First step is the balance the atom which undergo change in oxidation state. Here the iodine is undergoing change in oxidation state. So I am